Another review of inheritance on the chromosome level. This one deals with sex chromosomes and sex-linked inheritance. Now remember, chromosomes consist of autosomes and sex chromosomes. And sex chromosomes, of course, determine biological sex. Now, humans, many animals have what's called the XY system, where there are two different sex chromosomes, an X chromosome and a Y chromosome. And an individual with two X chromosomes is female, but having one of each would be male. So because males have two different sex chromosomes in the XY system, males are referred to as the heterogametic sex. Now, you can put chromosomes on a Punnett square just like you can put alleles on a Punnett square because it's the chromosomes by which we inherit them. So here we would have the mother. Half of her eggs would have this X chromosome, half of her eggs would have that X chromosome. Half of his sperm will have this X chromosome, and half of his sperm will have his Y chromosome. And if this sperm fertilizes this egg, baby girl. If this sperm fertilizes this egg, baby girl. If this sperm fertilizes this egg, baby boy. This one to this one, baby boy. You look at the ratio, it's 50-50. So you may have heard or read that the father determines the sex of the child. Well, this is the context in which that is true, because the father can donate an X or a Y chromosome, the mother can only donate X chromosomes. So when King Henry VIII was cutting off his wives' heads because they weren't giving him sons, it was his fault, but he didn't know any better because he did not take my class. Now, genes that are located on the X chromosome are called sex-linked genes. An example of sex-linked recessive disorders include red-green color blindness, hemophilia, and Duchenne muscular dystrophy. But we'll use red-green color blindness for our example. So it's carried on the X chromosome and it's a recessive gene. So here is an X chromosome with the normal gene, which is dominant, and here is an X chromosome tagged with the recessive allele for red-green color blindness, which is recessive. So a female can be a carrier of the allele and still have normal vision, whereas if he has the allele, he has red-green color blindness. See, sex-linked recessive traits show up much more often in males than in females because males have only one X chromosome and all the genes on it are going to be expressed no matter what. There's not a second chromosome with a dominant allele to cover it up like you would with the autosomes. Now over with these two Punnett squares, the top Punnett square has a cross between a mother that is not carrying the red-green color blindness allele and a father who has red-green color blindness. And if you look at the outcome, none of the children will have red-green color blindness, although all of the daughters will be carriers of the gene, and none of the sons will have red-green color blindness. Sons with red-green color blindness do not inherit the gene from their father. They get their Y chromosome from their father. Now, we carry her to the next generation. She is a carrier. Here is male normal vision. Oops, forgot one. Let me put that in. Half of the daughters will be carriers, half will not, but none of them will have red-green color blindness. But look here, we have the male with red-green color blindness who did not inherit it from father, but from mother. So sex-linked recessive traits skip generations, but they skip through the mother to the son. And this is our review of sex-linked traits.